this was, then I'll... Page 448? You said 45? 25, sorry. And today is the 21st, isn't it? Okay, so let's take a look. 448, 25. It's 7x plus 35. And everything divided by x squared plus 5x. The problem is really asking us to just simplify. So we are back to where we should start today because we want to pick problems from the book. So notice that the book does not say you must state restrictions. I'm going to kindly ask you to state restrictions because we know x over x is not 1 if x is 0. So how do I proceed? I'm asked to simplify this. That's all I'm told to do. So how do I start? You mean in the denominator? Okay, so we factor out x in the denominator and we get x plus 5. I agree with that. What about the numerator? Very good. And what is left in parentheses? X plus 5. So we have a restriction for this factor and another one for this factor. So a total of 2 restrictions. So what would you say? So x cannot be 0, and x cannot be negative 5. Now we are allowed to simplify. And what factor will go away? Yes, x plus 5 will go away, and that's why the simplified form is 7 over x, but it should include the correct restrictions. Good. Anything else? Did you have anything else? You cannot simplify as you did. Remember that? You cannot simplify in a sum or terms or part of a term. You have to completely factor before you simplify. Excellent. Okay, anything else? Anything else you worked on, or we go back to the book? Okay, so I'd like to look at a word problem. On page 449, so there are several applications here on page 448, page 449. One of them talks about revenue. Another one talks about cost. Another one talks about medicine. Next one talks about body mass. They're all rational expressions. Another one talks about the diameter of a skull. Another one talks about gross profit. Then another one is about the baseball player's percentage. So which one are you interested in? Anything?
Skull.
Okay, excellent. So that is problem 63. So let's take a look. Anthropologists and forensic scientists use a measure called the Cephalic Index. I hope I'm pronouncing it correctly. Index to help classify skulls. The Cephalic Index of a skull with width W, I'm taking notes as I read, and length L from front to back is given by the formula. Look at that. C equals 100W divided by L. A long skull has an index value less than 75. A medium skull has an index value between 75, so I'm going to have to take that. So a long skull has an index value less than 75. So the index less than 75. For a medium, the index is between 75 and 85. And the broad skull has an index value over 85. Index. Okay. Find the cephalic index of a skull that is 5 inches wide. So now I understand that that was not necessary, but I wanted to have it there. So width 5 inches and length 6.5. And classify the skull. Okay, so it's important. Good. So C is the cephalic index. So if the index is less than 75, the skull is long. If C is between 75 and 85, it's considered medium. And if C is greater than 85, that's considered the broad skull. What do I have to do? Any suggestions? How do I determine C? Just plug it in. Exactly. 100 times 5 divided by 6.5. And with the graphing calculator, 500 divided by 6.5, and I got 76.92. So what do we conclude? Is it long, medium, or broad?
Medium.
Yes. Good. So let's look at one more. Calculating body mass index is a way to gauge whether a person should lose weight. Doctors recommend that body mass index values fall between, so the body mass index, between 18.5, and this is problem 62 on the same page. Okay. The formula for the body mass index, B, is 703 times W divided by H squared, where W is the weight in pounds, and H is the height in inches. Look, another rational expression. Should a 148-pound person who is 5 feet and 6 inches tall, 5 feet 6 inches tall, lose weight? So the body mass index should be between 18.5 and 25. We are given the formula, as you see, a rational expression, W and H. W the weight and H the height in inches. So I cannot put feet in there, right? I have to change feet into inches. And we're asked, should this person who weighs 148 pounds and is 5 feet and 6 inches tall, should the person lose weight? In other words, if the body mass index is above 25, the person should lose weight. If it's between 18.5 and 25, the person should not lose weight. So what is the first thing I need to do? Change this into inches. So I have 5 multiplied by 5 feet multiplied by, very good, and plus 6. Right? So this is 66 indeed. Now I have that. All I have to do is plug it in to determine B. Becky, are you okay? You had a question? But is it clear what I'm doing or not? Okay. Okay, so with a graphing calculator, 703 multiplied by 148 and divided by 66 squared. Careful. So let's plug it in. Sorry, I should have had it ready. Okay, so 703. I can get away without parentheses here because I write 148, 703 times 148, and divide by 66 squared. Otherwise, in general, I would have recommended parentheses here in the graphing calculator and parentheses here. I can get away with it without parentheses in this particular case. Okay, so let's press enter. So it's 23.88 is within the range considered the range considered acceptable by doctors. So what will you advise this person, 148 pounds and 66 inches tall? Will you advise her or him to lose weight or not? No. She or he is okay. Yes. Yes, Becky, you had a question? Yes, I'm ready. Is there a problem? You could give me the problem. You said 11.2? 39? Okay. 39 and 11.2. We're refreshing our memory on chapter 11. That's good. 11.2, problem 39. 39. So use the quadratic formula to solve each equation. N minus 2 everything squared equals 2n. I recommend if you want to stop by, not this Saturday, but the following 2 Saturdays, I'll be here between noon and 2. Just a reminder, okay? Good. So we're asked to solve this equation using the quadratic formula. So what do I do? How do I start? Yes, I have to square n minus 2. What do I get when I square n minus 2? That's an agreement that we have for almost 3 months, right? So how do I square n minus 2? Let's try again. How many terms will I have to write? When we square binomial, how many terms do we get? 3 terms. And the 3 terms are?
N squared minus 4n plus 4.
Thank you. Becky, you remember that? N squared minus 4n plus 4, right? The first term squared minus 2 times the first times the second plus the second term squared. Is that okay? And then we subtract 2n and we have 0. We combine like terms. N squared minus 6n plus 4 equals 0. And only now we are ready to write the quadratic formula. Thank you, Chris. Everything done?
Yes.
The extra credit too? Awesome. Don't drink and drive. See you on Monday. He always laughs when I say that. Okay, so ready for the quadratic formula now? So negative b plus or minus b squared minus 4ac over 2a. See ya. You too. So from here I have n equals 6 plus or minus 36 minus 16 is 20, which is 2 to the square root of 5, as we know from the previous chapter. And again, I cannot simplify terms. So I can separate the fraction into 6 over 2 plus or minus 2 the square root of 5 over 2, or factor out and simplify, whatever you want. So it still is 3 plus or minus the square root of 5. Is that okay? Yes? Perfect. 43, same page? Okay, 43. In 43 we have 4x squared plus 12x equals negative 9. And we're asked here to use the discriminant to determine the number and type of solutions. So in order to determine this discriminant, first of all, we have to set the equation equal to 0. So we have all the coefficients, all terms, everything on one side. And the discriminant, if you remember, is this quantity. This is the discriminant, which is b squared minus 4ac. B squared is 12 squared, which is 144, minus 4 times 4 times 9, minus 4ac. So I'm looking at this, and if I'm looking at the trinomial, and I see that almost sure I expect this, right? So 2 times the first times the second is that. So that tells me that this must be 0. Because this is the factored form of this expression, and we know that it's going to have only one solution. Or just plug it in the graphing calculator. I was just lazy. So when you plug in the graphing calculator, you have 144 minus 16 times 9. And you will get 0. So what do we conclude when the discriminant of a quadratic equation is 0? What do we conclude about the solutions?
That's one real solution.
One real solution. Is that clear? Yes? Okay, perfect. Next question. Anything else, or we go back to 7.1? Anything else for us? Anything else? Okay, very good. Let me know if you find anything else. Okay, so we are back to page 448. We looked at those problems. Would you like to practice some more of simplifying, or we can move on to multiplying and dividing? We move on to multiplication? Okay, very good. So let's move on to section 7.2. On page 458, I would like to choose a problem, or you can choose a problem. Let's look at 46 on page 459. And this is 9x plus 18 divided by 4x squared minus 3x times 4x squared minus 11x plus 6. Everything divided by x squared minus 4. So let's work on this for 1 minute. Please raise your hand if you need my help. That's okay. It's a lot of work. So you want to talk about this one? Or something? Yes. Yes. You cannot change that, but you should factor this. You cannot do that. Remember, this is a trinomial. So you're looking for two numbers whose product is -4, and the sum is -4. So you have to factor the whole thing. Exactly, exactly. So you erase all this and write that. Do we need more time on this one? We do? Is that a yes? Is that a no? Is that a maybe? Is there anything? Okay, so what did you do with the top of the first fraction? Good. So what is left in parentheses? Very good. What did you do with the denominator? Excellent. What is left?
4x minus 3.
Very good. Now the top. I have to take it aside, multiply these two, right? So I'm looking for two numbers whose product is right and whose sum is right. Since the sum is negative and the product is positive, both have to have which sign? Negative, correct. So let's take that aside. So it's 4x squared minus 11x plus 6. And what do I do? So I need a negative and negative, correct. So I have 4x squared minus 8x minus 3x plus 6. Now what happens next? From these two, I factor out 4x, and what is left? Good. So I have to have x minus 2 coming out from the other two, and something in front. Sign and factor.
-3.
Very good. So finally, this is the common factor now is x minus 2, and then we have 4x minus 3. So I write it at the top, x minus 2 and 4x minus 3. And now what did you do with the denominator? Good. Good. How many restrictions do we have to state? Yes, 1, 2, 3, 4. So x not equal. Very good. Yes. Very good. Excellent. Perfect. So now I'm free to simplify because I stated all the restrictions. This is a product, so I can go ahead and multiply, simplify each fraction and also across. So what goes away? An x plus 2 from the top with an x plus 2 from the denominator. An x minus 2 from the top with an x minus 2 from the bottom. And 4x minus 3 with 4x minus 3. What is the simplified form assuming all conditions are fulfilled? 9 over x. Now, if the question is asking you to state the domain of this product, so this could be a function or an expression if you want. So what would you write as the domain of that whole thing? What would you say? In plain English. We don't have to write it. I'm just asking. What will you say the domain is? In other words, if I want to evaluate this expression, I can plug in anything I want except 0, 3/4, -2, and 2. So this whole thing is undefined at these points. So the domain will be anything but those. Good. Moving on to division, to refresh our memory, our mind on division. Yes? Okay. So let's look at, feel free to choose if you want to. 52 caught my eye. X squared plus 2x minus xy minus 2y over x squared minus y squared. I do not require you to state restrictions if there are two variables in the problem. You can, but if you just say, assuming all conditions are fulfilled, I'm fine. So for example, how will I write the restriction for this? I'm going to write x plus y not equal 0 and not bother with it at all. Not have to solve for anything. So it's okay. But I'm fine. Just state restrictions when you have an expression with only one variable. I'm fine with that. Okay, so let's work on this for a minute. Yes, I'm coming. I'm looking for my pencil. You got it. Right, so that was correct. So all you have to write here also is that x does not equal 9 and x does not equal -5. These are conditions. And the rest is good. Yes. Right. So if you remember, this is a binomial. It's a trinomial, and it's in descending order. You cannot apply a special product, but 1 is not the leading coefficient, but 5. So then the product of the numbers you're trying to find must be 10, and the sum must be 11. And once you determine those two numbers, then you will replace this. Is that better? Are we on the right track now? Okay. Yes, only because the leading coefficient is not 1. So you have to incorporate this with this in the product. Exactly. So now what you do, remember you replace this. Yes, exactly. Good? And it's safe to do that by simply covering the last 2. So factor out from here, write the product, the factor coming out from the 2, and then look at it. Okay, are we ready? So I'm looking at the top, and I see how many terms. How many terms? 4. What is the only method that we studied for 4 terms? Exactly. So from the first 2. Perfect, in parentheses.
X plus 2.
If this is the correct grouping, then I have to get x plus 2 from the other 2. If I don't, it doesn't necessarily mean that the polynomial is not factorable. Maybe I have to rearrange the terms in order to factor. I cannot immediately conclude, oh, not factorable. Do I have an x plus 2 there? What do we have in front? Negative y. Excellent. Perfect. What about the denominator?
X plus 4, that's right.
Very good. Divided by the top. The denominator, I cannot do anything to it, but the top needs 2. So we factor out a 2, and what is left? Yes. Are we okay so far? I should write x plus y not equals 0, x minus y not equals 0. That's fine. As I said, so plus or minus y not equals 0. So I'm fine when there are 2 variables. You don't have to worry about it. The book doesn't even show when there was only 1 variable, let alone 2. Okay, very good. So now I continue factoring out x plus 2 at the top, and what is left in parentheses? Yes, indeed, x minus y. And I go ahead and flip the second fraction, or change it into x plus y over 2 times x plus 2. Assuming all conditions are fulfilled, x is not negative 2, x plus y are plus or minus y are not 0. And now we are ready to simplify. What goes away? An x minus y with an x minus y.
X plus 1.
An x plus y with an x plus y. That's why I put 1. Be very careful, because you may think that this is 0 over 2 if you don't put those 1s. So careful. And the answer is 1/2. Of course, assuming all conditions are fulfilled and there is no undefined situation. Do we need more of multiplication and division? Or can we move on to adding and subtracting? Okay, I'll move on, and we can always go back. Okay. So on page 466, let's choose one with like denominators, and then move on to the real thing. 14. On page 466. 3x minus 1 divided by x squared plus 5x minus 6. And then minus 2x minus 7 over x squared plus 5x minus 6. Okay. 30 seconds. Okay, 40. Right. So just remember, you have to write here that x does not equal negative 2. Denominator cannot be 0. Okay? I also remember that there are a few things in here that we did not do. So if you would like to go back to these, unless you already solved them. If not, we can choose from the book or do both, whatever you want. Done? Everything? Extra credit?
Okay, so
Okay. Don't drink and drive. Just kidding.
I will not take it.
I know.
I will.
You too. So I copied the denominator, but I want to copy it factored already. How do I factor it?
X plus 6, x minus 1.
Very good. So now, can anyone dictate the numerator?
X plus 6. Oh,
Yes.
x minus 1 minus 2x plus 6.
Excellent. Very good. So you distributed, and obviously you changed the signs. Excellent. So then, indeed, x plus 6. Perfect. The expression has only one variable. I can simplify before I write that x cannot equal negative 6 or 1. And now I'm ready And the simplified form is
1 over x.
minus 1. Very good. Perfect. Okay. Now I think we should move on to 7.4 when we add and subtract rational expressions with unlike denominators. Would you like to choose anything from 1 through 60? Page 472. 1 through 60 on page 472. And then we move on to equations. If not, I'll choose. If you trust me, I'll choose.
Like this.
You trust me. Very good. Thank you. X divided by x squared minus 1 minus 2 divided by x squared minus 2x plus 1, of course. So let's work on this for a minute. Let me know if you need help. Okay, put my attendance in. Any help needed? Okay. No, because you did not factor the greatest common factor. You have to factor out 4. 4 is the greatest common factor. Right? You have to factor out the maximum possible. Ready to start together? What will you do with the first fraction? The top, remember when we add and subtract, we do not factor anything at the top, but denominators still have to be, all denominators have to be fully factored. So what about x squared minus 1? What do I do with that? Very good. Minus 2 over. Both these two are our agreement from 3 months ago. Very good. Now remember, the least, of course, I have to state 2 restrictions. Very good. Now remember, when we write the least common denominator, each factor has to have the highest power. But we're not adding powers. The highest is 2, I use 2. The highest is 3, I use 3. Okay? So now, what will be the LCD for this problem? All different factors, x plus 1, x minus 1. But now I have to look at the powers. There is nothing I can do to x plus 1. Power 1 stays with power 1. But x minus 1 has here power 1 and here has power 2. I have to use the highest. And now I have to identify the adjustments. What will be the adjustment for the top of the first, and what will be the adjustment for the top of the second? For this one, what it does not have. It has the x plus 1. It has one of the x minus 1. It's missing the other one. Here, this is here. But what it does not have is x plus 1. So the top of the first fraction has to be, if you want, adjusted by x minus 1, and the top of the second one by x plus 1. Do we understand this? Okay, can anyone dictate the numerator then?
X squared minus x minus 2x.
Very good. Is this clear? So then I have x squared minus 3x minus 2 over x plus 1, x minus 1 squared. I have to at least attempt to factor the numerator. So I'm looking for two numbers whose product is negative 2 and whose sum is negative 3. Can I find those numbers? If I can't find them, then the numerator is not factorable. So since the product is negative, I need a positive and a negative to get negative 2, which will only be negative 2 and 1. But negative 2 plus 1 is not negative 3. So there is nothing I can do. This is it. With the written restrictions. Any questions? Okay, do I choose another or you choose? Okay, let's look at let's look at 52. We have 2 divided by x squared plus 4x plus 4, and then plus 1 over x plus 2. 1 minute. In the meantime, I'm going to look for more. I don't want you to wait. Yeah, I'm going to write 57 as well. And then we can move on to equations. X plus 8, x squared, minus 5x minus 6, plus x plus 1, over x squared minus 4x minus 5. Yeah, the problem with that one is that it's, first of all, it's not in descending order. So you have to do this. Then you have to factor out -1. Yes, yeah. That's why we, in the strategy of factoring, we mentioned descending order all the time and then negative leading coefficient. No, because x squared minus 4 is negative x plus 2 and x minus 2. So if you write x minus 2 squared, then you get 3 terms. Careful for that. Okay, so let's start 52. So I have 2 divided by
X plus 2 squared.
very good. We have an agreement on that. Very good. Plus 1 over x plus 2. The only restriction is x not equal. Very good. And now the least common denominator has to have all different factors, but there is only one, at the highest power present that I see. I'm not adding powers. So what would be the LCD then?
X plus 2 squared.
Excellent. So then adjustments. For the first one, I don't need anything. By anything, I mean 1, right? Because it has the same denominator. But what will be the adjustment for the top of the second one? It only, exactly.
X plus 2.
Thank you. So then the numerator will be
2 plus x plus 2.
plus 2. Very good. Which is x plus 4 divided by x plus 2 squared. No one can further simplify this. This is it. Agreed? Okay. Are we working on the next one? Notice that these are not equations. These are expressions. In an expression, I can start from the beginning and say equals to the next simplified form and equals the next simplified form and equals. I can have as many number of equal symbols. But remember, in an equation, which we're going to get to in a minute, in an equation I can only have one equal symbol on each row for each equation. Is that clear? Okay, so let's start. What is the factor form of the denominator?
X minus 6, x plus 1.
Perfect. Plus x plus 1 over.
X minus 5, x plus 1.
Indeed. So you're going to give 3 restrictions then. There are 3 different factors. You're going to say 6, -1, and 5. Agreed? Okay, this is a slightly more difficult situation. Why? We haven't seen this before. How many factors we have in the least common denominator now? 3 different factors. So let's write them. X minus 6, x plus 1, x minus 5. Both numerators need to be multiplied by something. What will we multiply the first one by?
X minus 5.
What it does not have. It has x minus 6, it has x plus 1, it does not have x minus 5. Excellent. What about the second one?
X minus 6.
Very good. That's exactly what it does not have. It has x minus 5 and x plus 1, but it does not have x minus 6. If I multiply the bottom by x minus 6, I have to multiply the top by x minus 6. Perfect. Now be very careful because I need FOIL here and FOIL here. So please dictate.
X squared minus 5x plus 8x minus 40.
Excellent. Do you all agree with the first 4 terms? Okay, plus.
X squared
Yes.
minus 6x
Yes.
plus x
Yes.
minus 6.
Excellent. Again, I recommend multiplying as you see them up here and not write them because you may be tempted to simplify and that will be a mistake. But if you're comfortable with other methods, go ahead, use them, please. What will I have to do next? Bless you. What will be my next step?
Combine by 2.
Exactly. Now I will not be tempted to do anything silly. So I start with the highest degree, of course, which is 2x squared, right? So these are accounted for. Now, -5 plus 8, that's 3. -6 plus x is -5. And 3 minus 5 is -2x. Correct me if I'm wrong. Right? There is a +3 and a -5. So it's -2x. And then I have -40 with -6, which is -46. So x minus 6, x plus 1, x minus 5. Did we all get the same thing? Now, of course, I will try something at the top. There is no guarantee that I can do anything. But I have to try. So I will factor out the 2, and I get x squared minus x minus 23 divided by x minus 6, x plus 1, x minus 5. There is nothing I can do at the top. With the product of -23, which is a prime number, and a sum of -1, there is nothing I can do here. So this is it, assuming conditions are fulfilled. So all this, almost everything we did is for the next section, which deals with rational equations. So on page 479 and page 480, let's start with, let's say 16. So page 479, 480. This is major. This is a major topic. A plus 2 minus 5 equals 7a over a plus 2. I like to say to my students that once we got to this chapter, if you can handle adding and subtracting rational expressions with unlike denominators and equations, you have reached a level in which you could say, I have got algebra skills. So once you can play with these easily and find solutions and you're on the right track, then you can say, I have acquired algebra skills. So you have to factor out -11x squared at the top. So 11 is the common factor, x squared is another common factor, and you have a negative biggie coefficient. So you have to pull out -11x squared. Is that clear? So -11x squared, and you have something left in parentheses. What will be the first step? Let's work on this together, and then we'll find another or the next one to work on individually. So what will I have to do first? I recommend, if you like this method, use it. I recommend taking this term to the other side and changing its sign. But you have to have 0 on one side. So you copy 2a over a minus 2. You copy -5 over 1. And then -7a over a plus 2.
Is
Yes.
it supposed to be a plus 2 or a minus 2?
Oh.
Thank you.
Sorry. You're fine. Good. Now I find the least common denominator, and please remember the equal symbol and 0, because if you don't write the equal symbol and 0 on the other side, you will change it into an expression and you will not solve for anything, right? So one restriction is needed, which is a not equal Perfect. Now we find the LCD, which is actually only one. A plus 2. This doesn't need anything. By anything, I mean 1. This one needs something, and this one doesn't need anything. You can work on variations of this method. You could have moved 2a over a plus 2 to the other side, combine like terms. There are so many different ways. Choose the one you like. So what do I have to multiply 5 by?
A plus 2.
Correct. So can anyone dictate the numerator?
2a
Yes.
minus 5a
Yes.
minus 10
Yes.
minus 7.
That's it. Awesome. And of course, if you remember, in the next step, I do this. Just to remind me that I changed this into a proportion. And now, after I finally write the left-hand side simplified, then I can cross-multiply. So the denominator is a plus 2. But what is the simplified form of the numerator? So I have, this is negative 3 and minus 10. Minus 7 is negative 10, right? Negative 10a minus 10. So 2a minus 5a is negative 3a. Negative 3a minus 7a is negative 10a. And then I have a free term of negative 10. Now I'm ready to cross multiply. What do I get when I cross multiply?
Negative 10a
Equals. Excellent. That's why I like having Z0, because then it simplifies a lot. But there are other ways. You can multiply both sides by a plus 2 and so on and so forth. Okay, so this is a linear equation. Negative 10a equals 10, so a equals negative 1. Is it among the restrictions? No. So this is it. Any questions? Would you like to choose the next one, or you still trust me? Okay, number 19. 1 over x plus 3 plus 6 over x squared minus 9 equals 1. Okay, so let's work on this together, on individually and then together.